A-level statistics, an overview of averages, the mean. Let's have a look at averages. If we have a set of data, it's quite useful to find a value somewhere in the middle of the group that in some way is a good representation of all the data. There are three common ways in which this is done: the mean, the mode, and the median. These are all referred to as averages. When analysing data, the mean, the mode, and the median may have quite different values, and it's up to you to decide which is the most appropriate. There are other averages, such as the mid-value, which is halfway between the lowest value and the highest value of the data, but we'll concentrate on the original three. First of all, let's consider the mean. When most people talk about an average, they usually refer to the mean. The mean of a set of values is the sum of the values divided by the number of values. In other words, if you've got a list of numbers, you add the numbers together and then divide by the number of numbers. So, the mean is equal to the sum of the values divided by the number of values. For example, if we're asked to find the mean of the numbers 5, 8, 11, 6 and 8, to solve this, we add them together and divide by the number of numbers. So the mean is equal to 5 plus 8 plus 11 plus 6 plus 8, all divided by 5, which is 38 divided by 5, or the mean is 7.6. Now, in some ways, the mean is the most representative average, in that any change in any one of the variables will alter the mean. This may not happen with other averages. And the mean is what most people think of when talking about the average. It's also worth remembering, if we multiply across, we get the sum of the values is equal to the mean times the number of values. So, for example, if we know the average salary of all the employees in a company, we can work out the total salary bill for the company as the total amount is equal to the mean salary times the number of employees. Let's look at an example. The mean height of a group of 15 children is 1.46 meters. They're joined by another 3 children with a mean height of 1.82 meters. Find the mean height of all of them. Well, to solve this, if we look at the first 15 children, the total height of the 15 children is 1.46 times 15, which is 21.90 meters. If we look at the total height of the 3 children, that's 1.82 times 3, which is 5.46 meters. So the total height of all 18 children is those two added together, which is 27.36 meters. So the mean height of all the children is 27.36 divided by the number of children, which is 18, and that gives us 1.52 meters. So we have a mean of 1.52 meters. Now, quite often when we get a set of data, the data doesn't come in raw form. It's usually been put into groups, and we may need to find the mean of the group data. Let's have a look first at what happens with discrete data. Now here's an example. Suppose the number of children in each house in a road are put in a table. And we have some houses have no children, some houses have 1 child, some houses have 2 children, or 3 children, or 4 children. Now the frequency, that's the number of houses with no children, is 6. The number of houses with 1 child in it is 4. The number of houses with 2 children is 8. The number of houses with 3 children is 6. The number of houses with 4 children living in it is 1. And we're asked to calculate the mean number of children in each house. Now to solve this, we need to work out how many houses there are and how many children there are altogether. Now it's helpful if we add a row to the table, and that row is the number of children times the frequency. Now to get the number of houses, we simply add together the frequencies. There are 6 houses with no children and 4 houses with 1 child, etc. So altogether there are 6 plus 4, plus 8 plus 6 plus 1 houses, which is 25 houses. Now, to calculate the number of children, we need to multiply the number of children in each column with the frequency in each column. So there are no children in 6 houses, which is a total of no children. There's 1 child in 4 houses, so that's 4 children altogether. There are 2 children in 8 of the houses, so that's 16 children altogether. There are 3 children in 6 of the houses, which is 18 children, and there's 4 children in 1 house, which is another 4 children. So the number of children is 0 plus 4 plus 16 plus 18 plus 4, which is equal to 42. Now the mean number of children per house is the total number of children divided by the total number of houses, which is 42 over 25, or 1.68. And so we have a mean of 1.68 children. Now it's worth noting that although the number of children in a house is always an integer, the mean number of children may be a fraction. Now let's look at what happens with continuous data. Let's look at an example. Anglers caught 50 fish and weighed them. The weights, measured in kg, were grouped in a table. Now each group had a range. So the first group goes from 0.8 to 0.9. The second group goes from 0.9 up to but not including 1. And then 1 up to but not including 1.1, and so on. And in each group we're given the frequencies are 5, 8, 14, 13 and 10. Now we want to calculate an estimate of the mean weight of the fish. Since we don't know the exact weight of each fish, we obviously can't calculate the exact mean weight. However, we can get a reasonably good result. What we have to do is first find the mid-value of each group. We then assume that these are the mean weights of each group. Now the mid-value of 0.8 to 0.9 is 0.85. The mid-value of 0.9 to 1.0 is 0.95. The mid-value of 1 to 1.1 is 1.05. The mid-value of 1.1 to 1.2 is 1.15. And the mid-value of 1.2 to 1.3 is 1.25. And then we can work out the total weight of each group as the frequency times the mid-value. So the total weights are 5 times 0.85, which is 4.25, 8 times 0.95, which is 7.6, 14 times 1.05, which is 14.7, 13 times 1.15, which is 14.95, and 10 times 1.25, which is 12.5. So to get the total weight, we add them together: 4.25 plus 7.6 plus 14.7 plus 14.95 plus 12.5, which is equal to 54. And the number of fish is 50. So the mean weight is the total weight of the fish, which is 54 kg, divided by the number of fish, which is 50. And that gives us 1.08. So the mean weight of all the fish is 1.08 kilograms. It's important to remember that this is only an estimate because we don't know from the table the exact weights of the fish, but it is a very accurate estimate usually. Now sometimes when working out a mean, the numbers can be quite awkward, which makes the addition quite long and complicated. However, sometimes we can simplify it by using something called coding the data. Let's see what coded data is. To see this, we'll look at an example. Find the mean of the following numbers: 143, 147, 142, 145, 149, 152, 143, 141, 148, and 151. Now to solve this, we could add up the numbers and divide by 10 because there's 10 numbers. But this addition would be slow. We notice all the numbers are slightly higher than 140, So we could transform them by subtracting 140 from each of them. And this gives us 3, 7, 2, 5, 9, 12, 3, 1, 8 and 11. This is called coded data. Now we can find the mean of the coded data quite easily. We add the numbers together and divide by 10. That's 61 over 10. So the mean of the coded data is 6.1. Now since this is the mean of all the numbers reduced by 140, the mean of the original numbers is 6.1 plus 140, which is 146.1. So we've worked out the mean of the data is 146.1, but we have simplified the addition in the process. Let's look at another example. Find the mean of the following group data. Now this time we're given some classes going from 70 to 75, 75 to 80, 80 to 85 and so on, and we're told the frequencies 3, 12, 18, 10, 5 and 2. We're asked to find the mean, and so the first thing we'd do is we'd find the mid value for each class. So the mid value of 70 and 75 is 72.5. The mid value of 75 to 80 is 77.5, and so on. 82.5, 87.5, 92.5 and 97.5. We would now multiply the frequencies with the mid values and then add them up. But the calculations would be quite long even on a calculator because we'd have a lot of large numbers to type in. Instead, we can code the mid values. And we could do this by subtracting 72.5 and then dividing by 5. This will give us coded mid values of 0, 77.5 minus 72.5 is 5, divide that by 5 and we get 1, 82.5 minus 72.5 is 10, divide that by 5 and we get 2, and 3 and 4 and 5. We can now use these to find the mean of the coded mid values. We can now multiply the frequency with the coded mid value. So in the first row, the frequency is 3, the coded mid value is 0, 3 times 0 is 0. In the second row, the frequency is 12 and the coded mid value is 1, 12 ones are 12. And then 18 times 2 is 36, 10 times 3 is 30, 5 times 4 is 20, and 2 times 5 is 10. Now we can get the sum of the frequencies as 3 plus 12 plus 18 plus 10 plus 5 plus 2, which is equal to 50. And we can get the sum of the frequency times the coded mid values as 0 plus 12 plus 36 plus 30 plus 20 plus 10, which is 108. So that gives us a mean of the coded data as 108 divided by 50. Which is 2.16. Now to get the coded data, we subtracted 72.5 and then divided by 5. So to reverse this, to get the proper mean, we have to multiply by 5 and then add on 72.5. So the mean is equal to 2.16 times by 5 plus 72.5, which is 83.3, and so the mean is equal to 83.3. Now finally, let's just have a look at some commonly used notation. If we've got a set of numbers such as 2, 8, 6, 3, 9 and 5, we can represent this with a single variable x, which stands for a general term in that group. Now we can use the Greek symbol sigma to mean the sum of. So sigma x means the sum of all values of x. In other words, sigma x is 2 plus 8 plus 6 plus 3 plus 9 plus 5, which is 33. We also use x with a bar over the top to represent the mean of all the values of x. So x bar is equal to the sum of all the values over the number of values, or x bar is equal to sigma x divided by n, where n is the number of terms. Now if we've got group data, where x represents the mid-value of each group and f represents the frequency of each group, then x bar equals sigma fx over sigma f. In other words, the mean is equal to the sum of the frequencies times the mid-values over the sum of the frequencies. Now we can use this notation for coded data. However, in the formulae below, I wouldn't suggest you try and learn them. For raw data, we have the formulae. X represents the values of the data, n is the number of values of data, and a and b are constants. Then we have x bar is equal to sigma x minus b over n plus b. This says if we code the data by subtracting b from each of the variables to find the coded mean, we can add b back on at the end to get the mean. Also, we have x bar equals a times sigma x minus b over a all divided by n plus b. And what this is saying is if we code the data by subtracting b and dividing by a, and then finding the mean, we can then multiply this by a and add on b to get the mean of the original data. Now we can get similar formulae for grouped data. X bar is equal to sigma f x minus b over sigma f plus b. What that's saying here is x is the mid-value of the group, and if we code the mid-values by subtracting b and then find the mean of the coded data, we can add b back on at the end to find the original mean. In the fourth equation, we've coded the data by subtracting b and dividing by a. If we find the mean of the coded data and then multiply by a and add on b, we get the mean of the original data. Now I wouldn't try to learn these formulae. All you need to remember in brief is, if we make a linear transformation to the data and then calculate the mean, we must make the inverse transformation to the coded mean that we've just acquired.